We all know that the elimination of fossil fuels is a necessity, and the elimination of cars with gasoline, diesel, and gas engines will happen in the very near future. Currently, the latest human technology to reduce air pollution is electric motors, which are used in cars in two forms. First as a car with a fully electric engines, and the second as a hybrid car with two electric engines and fossil fuels. Of course, there are some electric vehicles equipped with hydrogen fuel cell, but currently they are not a logical solution, because for every kilogram of hydrogen that can be used in these vehicles, 10 kilograms of carbon dioxide gas is released, and this is very dangerous. Other ideas, such as using magnetic force and positive and negative gravity of magnets, are also in the early stages and unusable. For example, I've been working on an anti-gravity engine for nearly 20 years that have not yet achieved any good results. But today, I created a new idea for continuously moving a car using electric energy without the need for recharging. My invention is not very complicated because I use wind as a clean energy, and I just use my creativity to design its system. As you can see in the body design I did, I placed air intakes in the front of the car. I've tried to design the body shape in such a way that it gives maximum balance and aerodynamic while moving, because the wind is directed into the car with the speed and pressure. After passing through certain path and reaching maximum power and speed, it enters the fan chamber, and then from the other side passing over the battery panels and cools them and exits from the rear of the car. The fan blades cause the wind turbine to rotate so it can produce the electricity needed to continuously charge the battery. I did not use the acceleration and power of the electric engines or the power from the mechanical and physical movement of the wheels to generate electricity, so this is important and unique point of the system, because I kept the acceleration and torque of the engine because no force is applied to the engine. In addition, the electric engines and the batteries do not heat up and work better with entry of cool pressurized air from the outside. By my idea, there is no need to recharge the batteries using a DC power source or DC charging station on long roads. It's only necessary to charge the batteries once at first, and the AI checking system will activate the wind turbine as soon as it detects an decrease in electricity energy, and the batteries will be charged. This idea is much better and more powerful than generating very low electricity energy using the regenerative braking method in hybrid cars. Let's take a closer look at my idea. In my new electric car, the electric engines work independently and separately from the wind generator turbine. This means that the wind generator gets its rotational force from the wind, not from the electric engines or other mechanical parts. With this technique, we can increase the power efficiency and the speed of the electric engine. There are two large wind intakes in the nose and front of the car, exactly where the window is, usually between the headlight of the car. And I designed two other wind intakes, both sides of it close to ground. Each of them has a vane that directs the wind into the car to increase the intensity and speed of the wind. There is another wind intake on the top of the hood that sucks the airflow into the car from above. This intake is in the form of a closed box with 4 internal vents, which allows the air to enter the box and go to the 4 suction vents under the pressure of the external force and go to the turbine fan with pressure. The design of the wind path until it reaches the turbine fan depends on the car model. I designed the body to my sporty taste and designed the air and wind channel considering the free space under the hood of this car, which I named Pooraḥmad car just for fun. The wind enters the its suction intakes with multiple power and speed, then enters the fan chamber and rotates the rotor. The fan has 15 blades and connected to the main rotor and gearbox and then to the generator by a shaft. So as the rotor rotates, the main shaft rotates and the generator produces electricity. Due to the stability of wind power, because of the continuous movement of the vehicle, the output of the wind power generator of these vehicles is usually between variable values of alternating current, which must be rectified by charger and then stored in the battery. For this purpose, the generator output voltage is converted to DC voltage by the rectifier system, and then I use a controlled DC to AC converter to achieve the desired voltage and frequency. The generator in wind turbine produces alternating current electricity that we call it AC, but using it to charge batteries faster needs to convert this AC electricity to direct current or DC with a rectifier to store electricity in batteries, and then we use a controlled DC to AC converter to achieve the desired voltage and frequency to move the rotor of two electric engines are used in the car designed. For the wind turbine to be more effective, the car needs to be running at speed between 40 to 100 km per hour. That would mean wind speeds between 24 miles to 62 miles per hour. And according to computer simulation, this would be enough to charge the car's battery. Even at a speed of 60 km per hour, the DC power needed to fully charge the batteries is provided for 1 hour. Of course, it works at speeds below 40 km per hour, but in this range, it produces much less electricity. With this system, you will no longer need to recharge the battery on long trips. The future belongs to non-gasoline and diesel cars, so let's leave them as soon as possible and move toward pollution-free technology. Absolutely, my EV car that charges itself is one of the useful ideas for having a green planet. My name is Pooraḥmad. Please respect the copyright of my idea, and if you would like to know more details and use and purchase the rights of my idea, please contact me via email at the end of the video credit list. Thanks for watching.